Part 5, though, is different. Now, why is part 5 different? Well, I haven't told you what the derivative of tan is. But as a bit of a hint, we can actually work it out, just knowing what we have. Okay, so Matt's suggestion is that the derivative somehow incorporates an absolute value. Not a bad theory, right? There's actually 2 ways you can make something positive, though. An absolute value is one way, and squaring is another way. So that's kind of a hint about what to expect, because we saw that the gradient was always positive for tan.
Squaring makes more sense.
Sorry? Squaring does make more sense because where the heck does an absolute value come from in a derivative, right? But go back to this, right? I'm telling you that for part 5, that you can actually do it. Like not just from an observation standpoint.
Yeah, you're a genius.
What do you think, Matt? So my hint was that you actually know how to do it. How would you know how to do it if I've only told you sine and cos? Well, think about how else you can write tan. How else can you write it?
Which one's on sine over cos?
That's right. Well done, guys. You guys are crushing it. Sine on cos. But being careful to what I said earlier, what do we see here? We've got 2 fractions with both of them being functions. As opposed to this one where it was just x on 3, right? One was a function, one's just a constant. Don't have to apply a quotient rule here. But you've got 2 things in terms of x, that's when you do have to apply it. Just as a reminder for quotient rule, do it over here in red. If I have y equals to u and v, y dash is v squared, v dash minus v dash over v squared. So, have a go at that one. I think if you go to the point where you've got, alright, I've got my functions here and I can apply quotient rule, I know how to do that. Yes. Yeah. I just need to know my u's and v's. Now with the u's and v's, I still, a lot of the time, actually write out u's and v's in this. I'm actually just going to leave right now.
I'll do it on the board.
Hello, don't. Yeah? Oh, do that. Yeah. Okay, so we've got this over here now, right? So my u's and v's, I've got sine of x, I've got cos of x. I think some people are starting to realize, hang on. U dash and v dash. I'm looking at cos of x and negative sine of x. Let's put these together now. Can you help me out, Laura? What did you get?
I got cos squared x.
Yep, so we're doing v u dash. Remember, the reason why I like laying out like this is really easy to see which ones I need to multiply. Don't mix them up, Harry, not naming names. Yep, so we've got cos squared of x plus, Laura? Sine squared of x over cos squared of x. Now, before I keep going, now remember it's sine, well hang on, it's minus sine, sorry. Is it minus or plus?
Minus.
Oh, minus 1, yeah, so... Oh yeah, so just be careful with double negatives here, right? So, yeah, it's good, because you've got a negative here. That's strictly speaking negative sine squared of x, but as Harry said, there's a double negative, so I'm just going to do that. I'm going to cheat.
Oh, so it is also tan squared x plus 1 in the end.
What? Oh, sit tight, man. I don't know what you're up to. No. At this point, can I do one of these bad boys? No, why not, Laura? Okay, good. Just tricking you. Okay. But, Laura, what did you realize you can do to make this a bit nicer? Because I said there's a rule here that we're working with. Right, because that's a Pythagorean identity. Cos squared of x plus sine squared of x is equal to 1. And that's actually quite nice, because 1 on cos squared is pretty good, but we can actually go 1 further. This is a reciprocal function, and the way you remember is the 3rd letter there tells you which one it is. Oh wait, no, the 3rd letter in the original one tells you what it is, isn't it? In the new one, so that doesn't work. Yeah, there's no rule for that one. Sec squared of x. There we go. Terrible E. And the 3rd letter here tells you what it is, isn't it?
Based on the other identity, it's also tan squared x plus 1.
Plus 1, okay, so using the other 1 and a tan is something. Pythagorean identity, we can recognize that there's different forms for this. This is the form that we usually work with, right? So the accepted derivative for tan of x is sec squared of x. And we can write this in a similar fashion here, right, if we want to formalize it. Y is equal to tan of x, tan of f of x, sorry.
Is it equal to f dash of x?
Yeah, we've got y dash is equal to f dash of x,
Why?
sec squared f of x. There you go.
Wait. Then what's
Okay,
the,
jot that down for me.
and